everyone. I can see we have a slight imbalance in the room, much more people there, a little bit less here. But I'm very grateful that you made it after lunch. After all, it's not about the quantity, it's about the quality of people that attend the talk. So thank you very much. We knew that after lunch it's not going to be easy, so you are the rock stars. In the next 20 or so minutes, we'll be talking to you about our very practical, cost-effective implementation that we did internally for our teams, for our customer support teams. I haven't seen a lot of the presentations today that talked about the cost of implementation. So we will discuss this, but also we want to show you why it's important to do little implementations that give a lot of value to your organizations on a number of layers. But first things first, together on the stage with me is Dmitrii, who's working as the machine learning engineer in the Data&AI team at WebPros. And my name is Pawel. I'm the senior director and the manager of the same team, Data&AI at WebPros. Who are WebPros? We are providing solutions for the web enablement ecosystem. So basically everyone who wants to be present online. Digital creators, marketing agencies, hosters, you name it. So just to give you a perspective, we have more than 100,000 customers online. Our solutions manage around or more than 100 million websites, and we do business in more than 220 countries, just to set the scene. So in this presentation, I will start by providing you some business justification, why, from my perspective as a manager, it was very important to get engaged in a project like this. Then I will hand over to Dima to talk to you about our learnings from the implementation, and I will conclude with some results and the aftermath of the project. So I think we'll all agree that data and AI teams these days are in a pretty peculiar position in that we are given great tools that allow us to add value to our organizations, but our C-level executives and corporate sponsors require us to do more with less. Like we heard about this today a couple of times in the discussion panel, you know, use solutions like lovable.ai or .dev and try to increase your efficiency. And if we lose a couple of headcounts here and there, that's good for the organization, right? But if we talk to them and we say that in order to do things properly, you have to invest in LLM ops, in guardrailing, they tend to be reserved. And I don't blame them. So these numbers on the slide are just Q1 of this year in the headlines. How much money has been spent on the AI stage, right? So billions, millions. And when your executive hears that for a data center, Elon Musk had to build a dedicated gas turbine to power his GPUs, they start to think, well, this thing is expensive. Of course, these numbers don't relate to the projects directly, but they hook our sponsors on certain values, which is difficult for us as teams. That's why slow rollouts, little implementations that translate into pretty substantial added value for the organization is very important for teams like ours, Data and AI, to show the value without necessarily costing a lot of money. So what we did is we implemented this solution for our customer support team on 2 levels. First, when our customer comes to our ticketing solution and they start typing in what the issue is, we want to recommend them the best documents that can help them solve the issue on the spot. However, if this is not good enough and they end up creating the ticket, we want to augment the work of our customer support engineers by providing them content that allows them to solve the issue faster. So that's a pretty standard solution that we see these days, and like the transformer architectures are ripe for these kinds of solutions. We had 2 KPIs to measure our success. For the first one is the ticket deflection rate. So how many tickets that the customers started typing in ended up not being created because we think they used our recommendation. And the second KPI, what is the ticket resolution time? So how much faster our customer support engineers ended up resolving the ticket everything compared to our baseline. So that's by means of introduction, and I will now hand over to Dima to tell us about our learnings and experiences.
Thank you very much. So let's jump in with a quick summary of the current architecture. We have two parts. On the left side, we can see the customer journey. On the right side, the application part. And the heart of the system is a controller server. It handles all requests and all responses, transform text, chunk it, clear it, etc. And communicate with the other part of the system, like machine LLM, model, database, external knowledge sources. And everything goes through the controller, transform into embedding in our model, and store in the database. We have two main types of requests: put, to save new embedding, and get, to get the relevance article, the document, to solve the tickets. So based on this request, we will store or we will gather the articles. On the left side, we can see the customer journey, and if the clients have some problem issues with our product, he go to the ticket form. In our case, it's a Zendesk, and start filling the description of his problem in the ticket form. And before he finish his submitting the ticket, we show him the 5 articles, the documents, so related to the problem, so he can solve this problem himself. If for any reason he submit the tickets and these tickets go to the support team, this is one, they use our application as a semantic search with the natural net language to gather this information from the database easier and faster than the previous one. Easy peasy. Let's go next. So before creating a machine learning project, or basically any IT solution, we need to understand our clients, who we build for, how they use it, and why would they use it. Because if they have already some tools, why would they switch for our solution? Do we really make their lives better? We need to know how they would use it, because it depends on the technical part. Like, what the input, is it like image, video, or is it like text? And what the text? A few words, the whole novel, or something in between. So we can answer these questions, communicate with the domain knowledge experts, and then answer these questions, we can go with choosing the model, the right model for this project. Because it's always a trade-off, the accuracy versus the speed, the context versus the size of the model. And answer this, like the questions above, it's much easier to make your choice. So, for example, if you're creating the RAG system and the generative model takes like from the 10 seconds to the minute to generate the response, it's nothing like for a few seconds for embedding model, it's nothing compared to this time. But for the search engine, these seconds could be crucial. So let's talk about the size. Who think the bigger the better? Yeah, my wife don't, and I agree with her. So we measure the quality of the several models, the open sources on the left side, and from the ChatGPT API on the right side. On the first left side, the left chart, we use the same. We use the input as the name of the articles, name of the document. Basically, it's a summary, clean and clear and understandable. On the right plot, we use the real data, the description of the ticket, the messy one. They can contain logs, personal information, unrelated information, and you can see that on the y-axis we have MRP, MRR metrics. Who don't know what is it? It's like accuracy. Consider it this way. And on the x-axis, we have average time response. And as you see on the real data, we can see significant drop in accuracy in the metric. And not only that, but the best model, the biggest model on the left side, I'm not sure you can see this on the screen, but it's the biggest model with the more than 3,000 values in the embedding, drop from the first place to the third place. And this is model we use in our system as a custom fine-tuned model. It's always on the second place. So the bigger dimensional space doesn't always lead to the highest accuracy. The more related model with your domain knowledge, with your sources, much more efficient than the biggest model. I will choose the model that were trained on the similar data to your data. So let's jump to the databases. It's the second important part of this system we created, and this criteria is really important when you choose it. So who used the specified database, vector database? Nobody used. Who used traditional one? Yeah. So the problem with the specified vector base is that it's a nightmare for the DevOps team to handle it. It's new. Nobody knows how to use it. Nobody knows how to solve the problems. So the traditional database much more reliable. But you need to know, like, returning to the first slide with the second slide with the answers and questions. When you answer the questions, how they are going to use your system, you know what type of data you will receiving, and then if you have like something wild like images, videos, you need to specify vector database. So in most cases, when there is a choice between traditional databases and specified databases, in a 90% you will end up with the traditional databases with some extensions for the vectors. Because in most of the cases, you don't have like millions of the data, and most cases you will work with the text, only text. But there is some exception, like specified data, images or audio or something wild, and the scale. But with the scale, it's a tricky one. Suppose you have like millions of the items, and you need to like specify database to boost your performance. But the size will affect your accuracy. This is a funny chart. On the y-axis, we have the same MRR metric, and the x-size, we have a number of the items in the database. With the growth of the database items, we can see the plumbing the accuracy. I want to notice that this benchmark based on our data, and on your data, this result will be different. Maybe you won't see this significant dropping as we see, but there will be dropping in the accuracy in your metric, because it's much harder to get the highest result with the millions of data than like 10,000 or 1,000 items. So eventually, to increase your accuracy, you need to split your data in some chunks using some metadata, like in our case, solving the same issue on the Linux machine, on the Windows machine, they would be different, but the solution would be kind of the same, and we can split these solutions by the metadata, the Linux, the system, operation system type. So let's talk about the load balancer, the forgotten hero. With LLM, where the performance depends on the content length, it's important to change this old strategy with a new one. Because the least connections or the least response time doesn't work anymore. You can have one request with only few tokens, and the one request with 1,000 tokens. And you can imagine that the response time would be drastically different. So what we need is least context length in a strategy for the balance loader, especially if you have high load application. So suppose we have choose the model, you have choose the database, and you create your system. The most of machine learning and data science team jump right into the fine-tuning, the cool stuff. But before do this, I strongly suggest to extend the vocabulary before, if there is options for this. Like some models have blank vocabulary spaces, so you can replace their blank spaces with your specific word, slang, and it can boost your system as well as the fine-tuning. The next step would be finding the right metrics for you, so to measure the outcome of the fine-tuning, because we can do it worse. I've done the worse. It's a tricky thing, and you need to consider, based on this metric, does it worth to change the model? Because changing the model requires recompute the all embeddings in the database, and it could be millions. It could take hours to do this. And these metrics can help you to explain the business. Why do you need few more weeks or days? But my golden rule is always transform the machine learning metrics directly to the business metrics. Because let's be honest, it's really hard to explain the executives what's the ROC of AUK is, or F1 metric. It's like explaining the cat what the quantum physics is. They look interested in this, but all they think is food, in our case, money. But not in WebPros. In WebPros, we have great leadership, wise technical skills, etc. So in our case, the MRR metrics, it directly shows how they measure the positions that the right article document appears, what the place it takes. And with the help of the domain knowledge experts, we can transform these positions into something real for the business, like the deflection rate. In our case, the first place, so the first article, if it's the right article, we can have a 50% change to deflect the ticket. So the customer will solve it himself. We have 30% chance if the article appears on the second place, etc. With these numbers, we can transform the MRR metrics directly to the deflection rate. In this case, 0.2025 equal to the deflection rate at 11%. And this 11% we can easily transform to the money, because we know what's the cost of the one ticket solution. So, in summary, quick and simple, use the right metrics, and I will pass the rest to the Pawel.
Yes, thank you. So, I think it's worth reiterating that we use completely open source solutions. So the model, the embedding model that has been used, we took it off the Hugging Face, just making sure that the license is appropriate. The database was also an extension of the classical Postgre with vectors. So it's a completely, standing on the shoulders of open source giants, which means available to all. So what were the results that we got? So on the ticket deflection rates, we were able to increase that metric by 2.5 times. 11% of people who started to create the ticket ended up not creating it because they got a good enough recommendation from our system. And on the ticket resolution time, the entire customer support team was saving 120 hours per week, which is also a pretty substantial saving in time. But also, as Dima said, this is not the language that our executives speak. We can get excited about this, but our executives care about those things. When we calculated how much if it would have costed us to solve the issue, the tickets that would have been created without our system, plus the 120 hours per week savings, we're getting more than $200,000 savings annually with the running cost of the solution of 1.5K. Now, for me as a manager to present something like this to our executives is a win. It's a wet dream of every manager to be able to approach your executive sponsors with such numbers. And so one of the important things that we have to do as data teams is to be really loud and proud about what we do in our organizations, because historically data science teams were kind of sitting in the basements doing some stuff that nobody cared about. If we delivered something good, praise the Lord. But most of the time we were just like this thing that had to be in the organization because it's a buzzword to have data science teams. Like these days, we can really start delivering with high frequency and with big impact, but we still have to be loud about this. So what we did internally is we used mediums like the town halls, the newsletters, the dedicated Slack channels to brag about what we delivered. And we were recognized. Product people approached us saying, well, that's pretty good for a single product implementation. Can we have this in our products as well? So we are rolling this out to other products too. Also, the way the solution has been designed is very universal because this embeddings-based approach is, as I said, ripe for many different things. This use case for customer support is a classic one, but in a recent hackathon, one of the teams developed a solution to augment the work of QA teams, and they pretty much took the embedding solution off Dima's shelf and implemented this into their solution, greatly decreasing the development time. And something I want to once again reiterate, from my perspective as the manager, having a project that costs next to nothing but brings, 200K of savings per year positions us very favorably into the future. So we can come to them next time and say, look what we delivered with pretty much nothing. Give us more money to work on bigger projects, which is a great win. If you want to go a little bit deeper into what we actually did in this project and some details of how we did A/B testing, how we did benchmarking, please, you can scan this QR code or just Google this article that we wrote for medium.com for everyone's benefit to learn more about how we approach certain things. Also, the credit should go to more people that work on this solution. Apart from us here on the stage, it was a very big help from actually the customer support team who told us about all the domain specifics that were required. With that, we are pretty good with time, 6 minutes to go, so thank you very much for the attention, obviously, and we welcome any questions that you may have.